Yeah, I believe I am audible to all of you. Now, yeah, okay, thank you. So, you just tell me the doubts, whatever you have, I will clarify. Or otherwise, I will ask you the questions. You people can unmute yourself and respond to the questions. Okay? So, first, let me know what are all the different types of machine learning models. Explain mid questions. Explain mid questions. Mm. How many questions I had given to you? 5 or 6? Yeah, okay, five. Sixth question, it's a small question. That is the reason I did not. Fine. In yesterday's session, in a non-CRT session, I explained the machine learning, what is machine learning, and explain any four challenges in the machine learning. Okay. So, yeah, that's what I did not. I told you. Second question, you just ignore. Okay. So, first question is like, what is machine learning? What is machine learning? Machine learning. What is the machine learning? Can anybody? What is the machine learning? It is a subfield of basically it is a subfield of artificial intelligence. So we use the algorithms on our data set. The data set will be divided into parts: training set and the test set. So we apply the model on the training set. Once it is trained, it can be same model can be applied on the test data, and the prediction can be analyzed. Prediction can be analyzed. If it predicts correctly, then you can take that algorithm or that model onto the new data set, onto the new data set, unseen data set. You can, without human intervention, one can classify or one can predict or one can classify or one can forecast or one can find out the causal relationship between the variables of the data set. So that is what is the machine learning is. So in simple terms, it's a we can create a self-learning models, self-learning models. Self-learning models in the sense is once the algorithm is applied or trained on some data set, it cannot be reprogrammed or it cannot be changed. Self-learned. Okay, it will learn from the data set. It will try the model itself will find the unidentified patterns, which may be useful to make the decisions in the businesses. Okay, so machine learning models we can they are capable of predicting the outcomes. They are capable of predicting the outputs. So we are not working on the solution domain. We people are just working on the problem domain. Okay, so what we are expecting. The major challenges I already explained that even in the classroom or in yesterday's session. The first one is not enough training data. So we need large sets of data. So that is the reason only big data analytics came into picture. Okay, so there are various sources, specifically like applications like web applications or IoT devices or any device which is connected to the internet. We can collect the data from all those devices, and the data has to be cleaned in order to apply the machine learning algorithm or machine learning model. So as usual, just like the way we perform the pre-processing techniques, that is the data cleaning techniques, in data mining, in the same way, we go through and we apply the data cleaning methods on the data sets which we collected from various resources using the internet. Okay, so that is the we should have the enough data. So if you train the machine any machine learning model, maybe 10 records or 20 records, that may not be enough. We need to train the data model on millions of records. We should have the data set. Yeah, millions of records of data sets. So and that is the reason. So we need the large volumes of data. That is enough. That is the one. Okay. And then another one is, even though you have the large volumes of data, then the next question is like, what is the quality of the data? In the sense that that data, whatever data we collected, that should be trained on a particular model which may be useful, which may predict some value, which may be useful to the business in order to make the decisions. So quality of data is another challenge. The noisy data, missing values, specifically noisy data. So now we cannot apply any model on the noisy data. The noise has to be eliminated or removed from the data. So, for example, you want to perform some sort of sentiment analysis on the Twitter tweets, or on the social media networks, social networks charts. Like I want to find out the mood of a particular person based on the charts and based on the tweets. Okay, so if that is the case, it should not contain. It should the chart that is the chart messages or the tweets should contain only the words which are included in the dictionary. So then only we can analyze, we can apply some machine learning model to that is for analyzing the sentiments or find the mood of the persons. Okay, so that is but if it is a Twitter tweet, we need to eliminate all the hashtags and mail addresses and other things. It's okay. So short codes. Let's say, for example, PLZ. If you write uh, if you write something like PLZ in a WhatsApp chat or in a Telegram chat, really we don't have such word in the dictionary. So it has to be eliminated or it has to be elaborated. We should have the meaning of what actually the PLZ stands for. In few charts, people will say BRB. BRB is another short term or short code which will be used in charting applications. So if that is the case, we should that has to be expanded. What actually the BRB stands for? Okay, so data has to be like qualitative data. The data must be qualitative. Okay, so then only we can apply some sort of machine learning algorithm. Otherwise, we cannot apply any machine learning algorithm. This is the second one. And then I can say I talked about the non-representative training data. Non-representative training data. Non-representative training data in the sense is like while discussing this particular point in the classroom, I came up with an example. Way back in the 1970s, elections were conducted in US, and just like the way general elections were collected in the month of May in our country. So at that time, so many uh, news channels and other third parties, they predicted the voting results. So basically there are two companies at that time in the US, and one company selected a set of people like that is they approached the people using the mailing letters, electronic mails and other things. Okay, and there is another set of people whom this agency did not touch. So they don't have the feedback from from those people. They don't have the feedback from those people, and they did not collected the opinion from those people. That is the people who are not using or who are not following the TV or electronic mail system or another kind of a mailing systems. Okay, so they don't have the data from those people. In the sense, their prediction is wrong. It's going to be wrong, no doubt in that, because it's non-representation of data. That agency did not cover all the people in the society who are going to be part of the elections. So that is what I mean to say, the non-representation of the data. Okay, so non-representative of the data, that is the training data. Okay, so this is another challenge. Okay, and another one is irrelevant features. Irrelevant features. So this, while talking about this one, irrelevant features, we collected the data. It is not relevant for that problem. Okay, so non-representation is different than irrelevance. Non-representation in the sense is collected we left out some data which is useful to solve the problem. But whereas irrelevant feature in the sense is we collected the data that is not required. Okay. So that is the reason I say when it comes to irrelevant features, I say that it is garbage in, garbage out. So we collected the garbage data, and specifically the output is the prediction is going to be garbage out only. Of course, you can apply the same principle, garbage in and garbage out, when it comes to quality of data also. Okay, so these are the major challenges. When it comes to machine learning. Okay, so there is one more challenge also I discussed. There is one more challenge also that I discussed. I introduced. Okay. And there are few people waiting in the wait room. Okay. Fine. And when there is overfitting and underfitting of the data. This is also another problem. Okay. Another challenge. So overgeneralization, and see, the main objective of machine learning algorithms is like moving from specialization to the generalization, moving from specialization to the generalization. Specific principles, specific procedures, and specific outputs to inputs and specific outputs. We people are just moving to generalization procedures and generalized outputs. So that is what I can say about overfitting. Okay, overgeneralization. So most of the times we people do over expectations, and overgeneralization. Okay, so machine learning is also suffering from overfitting problem. Opposite to the overgeneralization, opposite to the overgeneralization is the underfitting. Okay, so model is too simple to learn something in the data. The same model has tough time to learn from the training data set. Okay, so in the sense the prediction is going to be wrong. Its prediction is going to be inaccurate, I can say. So either overfitting or underfitting, both will lead to inaccurate predictions on that. So these are the major challenges when it comes to machine learning. Okay, so you go through this question, and definitely maybe you can write, you can elaborate more on these questions. So next time I'll go through the statistical learning trade-offs. Now it is okay. My voice is okay. Voice is clear in the sense fast. Is it fast? Is it fast? Okay, that may be problem at your, you know, but maybe problem maybe at your side. It is a bandwidth question. It's a bandwidth question. Okay, so that may be the problem. So I'll just go slowly. I'll just go slowly so that you people can understand. Okay. Now is it okay? Now is it okay? Yeah, okay. Okay, thank you. I'll just go a little bit slow so that you people can understand. Okay. So the second question is like trade-offs. Maybe some other time we go with trade-offs. And there is one more question, generalized linear models. So you people have been introduced to two linear models. Okay, one is the simple linear regression, and the second one is the logistic regression. Simple linear model, and the second one is the logistic regression model. These are the two linear models uh, introduced to you. Okay, so simple linear. Remember, linear models most of the times we apply on the numeric data sets, numeric attributes. And remember, and try to remember that linear models we use for three purposes. We use for three purposes. One is for prediction purpose, and another one is for forecasting purpose, and the third one is like to find unusual relationships between variables or between attributes. Okay, so unusual relationships, that point you need to understand. So to understand this particular point, unusual relationships, I used to give one example. Most of the times I used to give one example, that is a relationship between the diapers and the beer tins. Beer tins. This is a classic example we go through when we talk about the data mining algorithms. So unusual relationships, hidden patterns, hidden in the data set. Okay. So for that we need to go through it, the diapers and beer tins. Actually, uh, uh, people have the tough time to understand what the relationship between the built-ins and the diapers. When diapers were introduced to the market, even they did not sell even one pack of diapers also. Okay, they changed the place of the diapers. That is, when you walk into DMart or some departmental store, items will be placed besides, that is, one item will be placed besides another item. So that is the placement of the item defines the sales of the particular item. Okay, the sales is basically dependent. The manager of the store is trying to find out the relationship between the items he is placing in the store. That is by knowing the relationship, The relationship over there is like increasing the sales. That is the end objective. So they started placing the diapers besides all the items, but there is no sales. But there is nobody had taken the diapers. Nobody had shown interest to purchase the diapers. But all of a sudden, one night, one day, the manager decided to place the diapers pack besides the beer tins. So it's really a surprise that no diaper pack was left at the end of the day. In the sense, the people bought the beer tins, they bought diapers pack also. See, really, we have the tough time to find out such type of relationship which is unusual between the items. In the same way, this is one example, okay? So, linear, the reason I had given this example is linear models we use for three purposes. We use the linear models for three purposes. One is for prediction purpose, the second one is for forecasting purpose, and the third one is for finding the unusual relationship. Okay, prediction is nothing but the forecasting only. To understand the prediction, say the example I can give you is the predicting the forecasting the stock prices. Prediction. It's a forecasting only. Okay, but it is not limited to time. It's not a time series problem. Prediction problems are not linked with the time series problems. When it comes to forecasting, in machine learning jargon, they limited to the time series only. That is only the minute difference between prediction and the forecasting in machine learning. Okay. Now, apart from that, logistic regression, remember once again, the linear models will be applied on the numeric attributes. If the data is categorical linear models, people will not apply the linear models. That is a linear regression model, specifically the regression models. But there may be situations where we need to predict, uh, predict some value. That is predict some uncategorical or predict some categorical data. Based on the numerical values. And it is going to be the categorical data. That prediction is always going to be something like either when we lose a match or win a match, or whether it will rain or not, whether a patient will suffer from cancer or not. Okay, so it is going to be, the prediction is going to be like this only. It's a binary only. And the prediction is always categorical only. Okay, but that categorical prediction is based on the numerical attributes. Okay, so based on the numerical attributes only. Yeah, the best example for to understand or to visualize this type of categorical prediction based on the numeric attributes, we go through iris dataset, classification of flowers based on the numeric attributes of the flowers, like width and length of the petals and sepals. That is petals and sepals of the flower. Okay, so that is the, and we can predict what type of flower it is, whether it is a rose or jasmine, what type of flower it is. But the categorical prediction is based on the numerical values only. And the prediction is always a binary only, not multi. Okay, we need to keep that one in the mind. So binary. Okay, such type of categorical prediction based on the numeric attributes And that is what is the logistic regression. That is what is the logistic regression. Apart from these two things, linear models, we have few models which are called as the generalized linear models. Generalized linear models. Okay. Okay. So shouting, madams. I'm shouting here. Okay. Generalized models. These are dependent on. Okay. These are dependent on. It uses the distributions, the statistical distributions. You need to understand statistical distributions like binomial, Bayesian, and Gaussian distributions. Okay. So we have three components in the generalized models. One is the random component, systematic component, and link function. Based on these three components, the generalized linear models are constructed. Okay. So I already discussed about the distance measures of ML algorithms. Distance metrics or distance measures. Distance-based methods are different, or they are different than distance metrics and distance measures. Distance-based measures are like KNN, K nearest neighbors. But the distance metrics are Euclidean, Manhattan, okay, and then Ski. I introduced the 4 or 5 distance metrics. We use this distance metrics to find the similarity between the data objects. That is one row of the data and another row of the data. You can use these distance metrics. So with this, you people have to understand that the similarity is also dependent on we can predict the similarity or we can find the similarity when the data is numeric. When the data is numeric, the attributes of the data set, the attributes in the data sets are numeric only. So then only we can find the distance. We can find the distance. The distance is nothing but we are trying to find the difference between one data point of the first row and the second data point, and another data point in the second row. I'm just trying to find out the difference. Based on the difference only, when it is plotted, when those two data points are plotted on a graph, whether they are going to be close or whether the distance that is whether they are going to be close or far. So that can be determined by computing or by calculating the difference. Okay. So and remember one more thing, that is the final point, that is linear models. Most of them, we use the linear equation. Linear models, we use the linear equations. And the linear equations will be plotted on a statistical graph as a line, as a straight line. Okay. That you need to note. Okay. Now, when it comes to this, is what is the logistic regression. The fifth question is about logistic regression. Of course, we can use the logistic regression for classification, for categorization, but the categorization is based on the attributes need not be categorical. The attributes need not be categorical. That you need to understand. Attributes are going to be numeric only. Columns in the data sets are going to be numeric only. Okay. So we use that, and remember this logistic regression is probability only. Basically, it is a probability. Probability may not be the probability which will be produced by the linear equation, that need not be 0 and 1. Maybe it may be greater than the 0 and 1. Always, no doubt in that it will produce a value greater than the 0 and 1. If that is the case, we need to go with only binary only. We need to go with only binary value, right? 0 or 1. We need to go with only binary. If that is the case, the probability which is greater than 0 and 1, it has to be reduced to 0 and 1. So that we can categorize. For prediction purpose only, we use the natural logarithms, and we use the inverse rules of the logarithm. We use the inverse rules of the logarithm, and we use the natural logarithms and inverse rules of the logarithm. Okay, on the linear equation, we apply both of them. We apply those things, logarithms and inverse rules of the logarithm on the linear equation. Okay, so in the sense we start finding the odds. Okay, we start finding the ODD odds. Odds is nothing but it is the ratio of the probability. It is the ratio of the probability of an event occurring to the probability of an event not occurring. That is the ratio of the once again I repeat. Okay, odds is nothing but it's a ratio of probability of an event occurring to the probability of an event not occurring. That is the odd. So the linear equation will be transformed to odds. The linear equation will be transformed to the odds. After that, okay, we apply the logarithm on the odds. We apply the logarithm on the odds. Natural logarithm on the odds. Okay, so then we perform the exponential operation. After the exponential operation, we go with the inverse rule of logarithms. We apply the inverse rule of logarithms. And then we use the simple algebraic manipulations like multiplication and division. We use simple algebraic manipulations. Then we reduce the probability to 0 and 1. Probability, we reduce the probability such a manner that the probability will always be between 0 and 1. In the sense, it's going to be binary only. If the probability is greater than 1, or if the probability is not between 0 and 1, the categorization is not going to be a binary, it's going to be a multiple, which cannot be performed using the logistic regression. Okay, so we can say that the logistic regression is a binary classifier. Okay, it's a classifier. Of course, it's not a multi-level or multi-layer classifier. It is only a binary classifier, which will be applied on the numeric attributes. Okay, so this is what is the fifth question. Okay, and the sixth question is like Bayes theorem, Navy Bayes theorem. The Navy Bayes theorem, which is based on the Bayes theorem, Okay. Yeah, I believe I explained the fifth question also. What all operations we perform in fifth that is in logistic regression? Linear equation to odds. After applying the odds, we apply the natural logarithm. Okay. After the natural logarithms, we go with the exponentiation. After exponentiation, we go with the inverse rule of logarithms. After inverse rule of logarithms, we apply some perform some algebraic manipulations like multiplications and divisions, and we reduce the probability to 0 and 1. That is less than or equal to 1. Okay. So these are the operations. If you can remember those operations, you can write about the logistic regression. Okay. And then any doubts here? Fine. I believe you people can write the examination. One thing is like people have to practice. Unless you practice, unless you practice the machine learning models, that is the theory related to the models, uh, you cannot understand. You need to put into practice. So that is the reason I'm asking you to work on the download the required. I'm sharing the required libraries. I'm asking you to download. Even I'm ready to help you people to download. I asked you to submit our laptops so that I can install it to me, so that I can install the required libraries. I showed how to install the required library. Okay. But I explained the fifth question, I believe. If you have any doubts, you can ping me. I'm here to clarify your doubts. You can just ping me in the chat box, or you can raise the hand. Third 3 minute questions. Was Basha did not expected. I had given you only 5 questions, no? And I asked you to prepare for 3 questions. I asked you to write 3 questions. I had given only 5 questions. For the sem and examination, you need to prepare not less than 20 to 30 questions, 30 to 40 questions.